welcome to Cambridge Chemistry channel with sarwatAhmed. Be sure to like the video and subscribe the channel. This is really helps the channel to grow. In this video I will discuss the second part of the mole calculation from 2015 to 2022 past paper questions. A sample of 2.30 gram of ethanol is mixed with an excess of aqueous acidified potassium dichromate 6. The reaction mixture is boiled under reflux for 1 hour. The required organic product is then collected by distillation. The yield product is 60%. So first write down the chemical equation of ethanol. So this is ethanol when it is oxidized in the presence of acidified potassium dichromate. It is acidified to form ethanoic acid and water. So 2.30. So first calculate the mass of mole of ethanol. So this is mass over, the formula is mass over mR. So 2.30 is mass of ethanol divided by mR is of ethanol is 46. So the mole is 0.05. So by using there is 1:1 mole ratio, 1:1. So we get mole of ethanoic acid 0.05. So by using this formula, mass is equal to mole into mR. So mole is 0.05 into 60, that is 3 gram. And we know the yield of product is 60%. So this is, and which mass of product is collected. So we need to calculate the experimental mass and this is the theoretical mass which I have calculated. So by using the formulas, mass experimental divided by theoretical yield. So 60 is the percentage yield is given. So this is mass of product collected divided by theoretical yield into 100. So 100x is equal to 60 into 3, that is equal to and x is equal to divided by 100, 1.80 gram. So this is the best option, 1.80 gram. So next question is the structure tartaric acid is shown. So this is the tartaric acid structure. 4 moles of substance X react with 1 mole of tartaric acid. So this is what could be the substance X. Sodium react with this alcohol ONA. Sodium also react with this alcohol ONA and also react with this alcohol ONA, also react with this alcohol ONA. So there is 4 moles of substance X react with 1 mole of tartaric acid. So A option could be correct. So B option, we can calculate sodium carbonate react with the carboxylic acid but cannot react with alcohol. So 2 moles of sodium carbonate is required, so that's why it is incorrect. So similarly, sodium hydrogen carbonate also react with carboxylic acid. 2 moles of sodium hydrogen carbonate required but cannot react with alcohol. So and sodium hydroxide also react with the carboxylic acid. 2 carboxylic acid are there in this compound, but alcohol cannot, sodium hydroxide cannot react with alcohol. So that's why this is also incorrect. So that's why A option is correct. So next question is substance Q is a hydrocarbon. When 1 gram of Q is completely burnt, 3.22 gram of carbon dioxide is produced. So let's calculate what could be the identity of Q. So you have to calculate like this. First write down the chemical equation of cyclohexane, C6H10. Cyclohexene, C6H10, and this is the chemical equation. React with oxygen to form carbon dioxide and water. By balancing the carbon dioxide, this is 6, place 6 over here and 10 and 5 over here. So we have 6 to the 12 and 5 17 are the total number of oxygen atoms. So here by using 8.5 divided by 2, that is equal to 17. So 3.22 gram. So this is carbon dioxide. So 3.22 gram, the MR of cyclohexane is 82 and MR of carbon dioxide is 44. So we know that from this chemical equation 82 gram produces 6 into 44. So what would be the mass of carbon dioxide when 1 gram of cyclohexane react with oxygen? So the mass of oxygen is, this is by using cross multiply. By using cross multiply we get 6 into 44 divided by 82. So this is 6 into 44 divided by 82. So mass is 3.219, which is equal to 3.22. So A option is correct. So similarly we can calculate cyclopentane. We can check cyclopentane like this: C5H10 and plus oxygen to form carbon dioxide water. So 70 molar mass of cyclopentane is 70 and molar mass of carbon dioxide is 44. So 70 produces 5 moles of carbon dioxide. So what would be the, if 1 gram of cyclopentane react with X? So the answer is 3.14. so that's why it is incorrect. So you can calculate ethene and pentane like this. So next question is, what is the minimum mass of oxygen required to ensure the complete combustion of 12 dm cube of propane measured under room conditions? So this is 12 dm cube. First calculate the mole of carbon dioxide, mole of CO2, that is 12 divided by 24, the mole is 0.5. So we have to calculate minimum mass of oxygen required. So by using mole ratio, 5 moles of oxygen, so by using mole ratio 1:5 and 0.5:x. So we have moles of oxygen is 2.5. So mass is equal to mole into MR. So MR is of oxygen is 16 into 2 32. So 2.5 into 32 is equal to 80. So 80 gram of oxygen is required to burn propane. Next question is, how many moles of hydrogen are evolved when an excess of sodium metal is added to 1 mole of citric acid? Hydrogen gas. So we know that 1 mole of sodium react with this compound. Look at here, over here sodium, over here sodium, over here sodium, and over here sodium. So 4 atoms of hydrogens are released and which form H2. So H2. So balance this reaction, we place 2 over here. So in this way this compound is formed. This is the product. Carboxylic acid react with sodium, this carboxylic acid react with sodium, this carboxylic acid react with sodium, and this is all. Alcohol also react with sodium. So this is the product, and plus hydrogen gas. So by balancing this reaction So we place 2 over here because 1, 2, 3 and 4 hydrogen are there. So that's why 2 moles of hydrogen gas is required, is produced. So next question is, a sample of propane C3H8 with mass of 9.61 gram is completely combusted in an excess of oxygen under room conditions. Which volume of carbon dioxide gas is produced? So by calculating mole of propane, 9.61 divided by 44, so this is the mole of 0.2184 is the mole. So by using mole ratio 1:3, so this is the 0.2184 ratio x, so we get moles of carbon dioxide is 0.6552. So by multiplying, this is the volume of carbon dioxide mole into 24 dm cube, so we get 15.7 dm cube of carbon dioxide gas is produced. Question number 76, anhydrous magnesium nitrate decomposes when heated given a white solid and a mixture of two gases X and Y. Y is oxygen. So what is the ratio mass of X and Y? So this is the chemical equation. Magnesium nitrate gives magnesium oxide and nitrogen dioxide and oxygen gas. So this is the colorless gas, and we know that MR of nitrogen dioxide is 46, mole is 4, so this is 184. The ratio of these two gases are 184 over 32, which is simplified to get 23 over 4, and 23 over 4 is equal to 5.75. So if we know that 1 mole of oxygen, this is 1 divided by 5.75, this which is equal to 0.174. So that's why A option is correct option. Next question is, citric acid is found in lemon juice. So which volume of 0.40 mole per dm cube sodium hydroxide solution is required to neutralize a solution containing 0.0050 mole of citric acid? 12.5 centimeter cube is the best option, and we know that how to reach this option. So first calculate the volume of citric acid. Volume of this is volume, which volume of sodium hydroxide? So sodium hydroxide is going to calculate. So volume is so mole ratio is 1:1. So that's why volume is equal to 0.005 divided by mole over concentration 0.40. So it is equal to 12.5 centimeter cube. So the formula is volume is equal to mole over concentration. So next question is 0.005 mole of sample of anhydrous calcium carbonate is completely thermally decomposed to give 100 centimeter cube of gas. In a separate experiment carried out under same condition, 0.005 mole of sample of anhydrous calcium nitrate is completely thermally decomposed. The volume of gaseous product is measured. What volume, total volume of gaseous product is produced from the calcium nitrate? This is a reaction of calcium carbonate. Calcium carbonate gives calcium oxide and carbon dioxide, and this is decomposed to give 100 centimeter cube. Now we know the chemical equation of calcium nitrate. Calcium nitrate, to form calcium oxide, and 2 moles of nitrogen dioxide and half moles of oxygen. So this is 0.005 mole of sample of anhydrous calcium nitrate is thermally decomposed. The volume of gaseous products is measured. We know that 1 mole this is 100 centimeter cube. So we know that 1 mole of calcium nitrate gives 2.5 moles of nitrogen dioxide. This is 2.5 moles. Total moles are 2.5 moles. And what would be the mole of these gases when 0.005 mole sample of calcium nitrate is thermally decomposed? So we get 0.0125 is the total volume mole of gases, mole of NO2 plus oxygen. So this is 0.0125. So we know that 0.005 moles produces 100 centimeter cube gas. So what would be the gas if 0.0125 mole react? So ratio X, mole ratio volume. So 100 contains 0.005 or 0.005 contain 100 centimeter cube of gas. So 0.0125 producing X. So this is equal to 250 centimeter cube. So D option is correct option. Next question is sodium azide. Sodium azide decomposes as shown. Which volume of nitrogen measured at room temperature and pressure will produced by the decomposition of 150 gram of sodium azide? By calculating mole of sodium azide is mass over MR. 65 is the MR of sodium azide, so we get 2.307 moles by using mole ratio 2:3. 2 moles of sodium azide producing 3 moles of nitrogen dioxide. So what would be the mole when 2.307 react? So this is the mole of nitrogen 3.46. So multiplied by volume is equal to mole into 24 dm cube. So the answer is 83 dm cube. So this is the B is the best option. Ten centimeter cube of ethane is burned in 45 centimeter cube of oxygen at pressure of 101 kilopascal and a temperature of 200 degrees centigrade. Complete combustion takes place. What is the total volume of gas produced present when the reaction is complete, measured under same conditions? So we know the reaction of ethane when react with oxygen to form carbon dioxide and water. So we know that if 10 centimeter cube of this is mole ratio volume, if 10 centimeter cube of ethane is burned, it gives 35 centimeter cube of oxygen, producing 20 centimeter cube and plus 30 water, because this is 101 kilopascal and temperature is 200 degrees centigrade. This is not at room temperature and pressure, so that's why water exists in gaseous state. So we can calculate, we can add volume of steam as well. So the volume of by using mole ratio, if 10, this is 35, to ratio get 20 centimeter cube, and this is 3 moles ratio C2H6, we get 30 centimeter cube of gas. So total gas of carbon dioxide and water are 50, and the oxygen, maximum oxygen is used in excess. This is 45 centimeter cube. Out of 45 centimeter cube, 35 centimeter cube of oxygen is used. So 10 centimeter of oxygen is left behind in the product, and total volume would be this is 50, carbon dioxide and water is 50 centimeter cube, and this is oxygen gas, this is carbon dioxide and water, and we get 60 centimeter cube. The answer is D. Next question is 6.90 gram of an aluminium ammonium salt is heated with an excess of aqueous sodium hydroxide. The volume of ammonia produced measured under same conditions 12.51 dm cube. 2.51 dm cube. So we know the chemical equation: ammonium sulfate plus sodium hydroxide to form sodium sulfate, ammonia and water. By balancing this equation, we know that 6.90 gram of ammonium salt. We use ammonium salt, this is the best option, so I calculate only this option. So rest of the calculation you can check by using the same method. 6.90 divided by 132.1, this is the mole of ammonium sulfate, and the moles are 0.05. By using mole ratio 1:2, ammonia gas, volume of ammonia gas is 2 moles, so 0.05 ratio x, so we get 2.507 mole, and volume is 2.5 dm cube of the volume, and it is the ammonia gas. 2.51 dm cube of ammonia gas is produced by using ammonium sulfate. So you can check rest of the options by using the same method, and so D option is correct option. Next question is 0.25 gram of anhydrous magnesium nitrate is heated strongly until it completely decomposes. What is the total volume of gas produced measured under room conditions? We know that 0.25 gram of magnesium nitrate is heated. What is the total volume of gas? So this is the same which I have solved earlier. So let's solve this question. Why this is left? Magnesium nitrate MgO, nitrogen dioxide plus oxygen gas 2. Magnesium nitrate is 24 plus 28 plus 3 to the 16 into 6. 24 plus 28 plus 16 into 6 is equal to 148. So 0.25 divided by 148. So this is equal to 0.25 divided by 148. This is equal to 0.0016. What is the total volume? So this is the mole of magnesium nitrate. By using mole ratio 1:2.5, 0.0016 ratio x, 0.0016 multiplied by 2.5 is equal to 0.004. 004 into 24,000. This is volume of gas, total volume of gas, into 24,000 is equal to 96. Sorry, this is 0.0016. 0.0016 into 2.5 is equal to into 24. So this is equal to, please take whole number ratio, 0.0014421 into 24,000, that is equal to 101.1. So C is the best option. So next question is, a copper ore contains 3% of copper carbonate by mass. Which mass copper would be obtained from 1 ton of the ore? So we know that this is the MR of the copper to carbonate. Copper to carbonate ore containing copper to carbonate. 100, if 3% is there, 100, 3% of copper to carbonate in 100. And what would be the in 1000, 1 ton? Ratio X, this is 30 kilogram. So copper ratio copper to carbonate. So this is MR of copper to carbonate contain AR of atomic mass of copper is 63.5. What would be the mass of copper in 30 kg of ore? So this is equal to 15.4. So question number 84. Next question is, in this question you should assume air contain 21% oxygen. What is the minimum volume of air required to ensure complete combustion of 10 centimeter cube of butane? So this is the butane, C4H10 6. So this is the complete combustion of 10 centimeter cube butane gives 65 centimeter cube of oxygen gas by using mole ratio. We know that mole is directly proportional to the volume of gas. If 1 mole of butane is this, so for 1 mole 10 centimeter cube is used, and if 6.5 moles, so mole ratio volume is equal to 65 centimeter cube of oxygen is used. So if we know that 100 in 100 percent of in 100 gram of air contain 21. So what would be the mass if 65? This is the volume of oxygen, and this is the 100 centimeter cube contain 21, and 65 centimeter contain X. This is equal to 310. So this is the D is the best option. Next question is again the same question I have discussed earlier, 2-3 questions like these. Magnesium nitrate decomposes when heated to give white solid and mixture of gases. One of the gases released is an oxide of nitrogen X. So this is the magnesium nitrate, and this is the chemical equation. 7.4 grams, so by calculating mole is equal to mass over MR. 7.4 divided by 148.3, this is equal to 0.05, and by using mole ratio, nitrate until no heating. Oxide of nitrogen X. So what mass of X is produced? We know that by using mole ratio, 2 moles of we get moles of nitrogen dioxide. So this is equal to 0.1. So mass is equal to mole into mR. So mR of nitrogen dioxide is 46, mole is 0.1. The mass is 4.6. So D option is correct option. Strontium metal can be extracted from strontium oxide by reduction with aluminium. One of the possible reaction is shown. What is the maximum mass of strontium metal that can be produced from the reduction of 100 gram of strontium oxide using this reaction? Okay. So moles of strontium oxide is 100 mass over mR. So strontium oxide is 103.6, 87.6 is strontium, plus 16 is oxygen. So this is equal to 103.6. The mole is 0.965. By using mole ratio, strontium oxide and strontium metal. This is strontium oxide ratio strontium 6 ratio 3, 0.965, and we get mole of strontium 0.4825. So mass is equal to mole into AR. So AR is 87.6. This is the mole, and we get the answer is 42.3. So B is the correct option. Next question, an ore of magnesium contains 4% by mass of manganese dioxide and no other manganese compounds. 100 containing 4, and what would be the 1000, 1 ton, 1000 kg is equal to X. So this is equal to 40 kg, 1000 kg. So MnO2 reaction is this, MnO2 to form Mn plus O2. 86.9 gives 54.9 gram of manganese. So what would be the manganese when 40 kg is used? So this is equal to X. So this is 25.27. By cross multiplying we get 25.27 and approximately 25.3. So this is the best option, 25.3. So next question is, a white powder is known to be white powder is known to be mixture of magnesium oxide and aluminum oxide. 100 centimeter cube of 2 mole per dm cube of sodium hydroxide is just enough to dissolve the aluminum oxide in x gram of the mixture. The reaction is shown. 800 centimeter cube of 2 mole per dm cube of HCl is just enough to dissolve all of the oxide in x grams of the mixture. The reaction are shown. So this is the moles of aluminum oxide and sodium hydroxide. So we get the moles of sodium hydroxide is 0.2, and by using the mole ratio 0.2 we get the mole of aluminum oxide, that is equal to 0.1. Okay, now 800 centimeter, why this is 1.6, this is 1.6 moles of HCl which is used over here. So mole is 1.6. So by using mole ratio 0.1 ratio X and 1 ratio 6, this is the mole of H positive which is used over here to calculate. So this is equal to 0.6 mole. So the mole which is used is 1.6, and mole of aluminum oxide, we subtract the mole from the original mole. This is mole of aluminum oxide, 0.1. We know that the mole of 0.1 is 1:2, and magnesium oxide is this is 0.6. By subtracting this mole, we get the mole 0.6, and we know that 1 mole of magnesium oxide. So this is the 0.10 is the mole of aluminum oxide in the mixture. So this is X, and we know that the 1 mole is left behind. This is the 1 mole left behind because 0.6 mole is used, and 1 mole of H positive minus 0.6 is equal to 1 mole of hydrogen ion is there. So 1:2. So if 1 mole of acid is there in the mixture, so what would be the mole of magnesium oxide? So the mole of magnesium oxide, by using mole ratio, we get mole of magnesium oxide is 0.50. So this option is correct. So D option is correct. So first you have to calculate mole of sodium hydroxide, then mole of aluminum oxide. In the reaction, this reaction, mole of aluminum oxide is 0.1. So the mole used, mole of aluminum oxide which is react with the HCl is 0.6, and we know that actual mole of HCl is 1.6. So this is aluminum oxide, this is HCl mole used. So the left behind is 1 mole. So we know that in this reaction, magnesium oxide, we have to calculate mole of magnesium oxide by using mole ratio. If 1 mole is there, so X mole of magnesium oxide is 0.50. So you know that next question. So next question is, a 3.7 gram sample of copper 2 carbonate is added to 25 centimeter cube of 2 mole per dm cube hydrochloric acid. Which volume of gas is produced under room conditions? So this is 3.7 gram. First calculate the mole of HCl and mole of copper 2 carbonate. This is the MR of copper 2 carbonate by using mass over MR 3.7 over 123.5. The mole is 0.029, and mole of HCl is concentration into volume 2 into 0.25. 0.025 is equal to 0.05. So the moles of because 1 mole of copper 2 carbonate is using 0.0299 mole, while 2 moles of HCl is using 0.0 divided by 2. So this is the limiting mole. This is the limiting mole, and this is excess. And you know, mass of product depends on the limiting mole. Once limiting reactant is used up, reaction is over. So by using mole ratio with the HCl and carbon dioxide, 2:1, 0.05 ratio X. So the answer is of mole of carbon dioxide is 0.025, and volume of volume is mole into 24 dm cube. So the answer is 0.6 0.60 dm cube. So A option is correct option. So next question is, a washing powder contain sodium hydrogen carbonate as one of the ingredients. In a titration solution containing 1 gram of this washing powder requires 7.15 centimeter cube of 0.100 mole per dm cube sulfuric acid for complete reaction. The sodium hydrogen carbonate is the only ingredient that reacts with the acid. What is the percentage by mass of sodium hydrogen carbonate in the washing powder? So by using the mole is equal to concentration into volume, we get the mole 0.00415. The chemical equation for this reaction is this: sodium hydrogen carbonate react with sulfuric acid to form sodium sulfate, water and carbon dioxide. So we know that 0.00415 by using mole ratio 2:1 and 0.0075 moles of sulfuric acid ratio X. So the mole of sodium hydrogen carbonate is 0.00143 and mass of sodium hydrogen carbonate is 0.00143 into mR of sodium hydrogen carbonate mole into mR. So we get 0.12 and this is 12%. So 0.120 in 1 gram divided by 1 into 100, that is the percentage by mass is 12 gram. Sorry, 12%. So C option is correct option. Next question is, in this in this question it should be assumed that ammonium hydrated ammonium carbonate dissolves in water without causing an increase in volume. Which mass of ammonium carbonate should be added to 800 centimeter cube of water to form a 0.100 mole per dm cube solution of ammonium ions? First calculate the mole of ammonium ions. 0.1 into 800 divided by 1000, this is equal to 0.08. So by using mole ratio 1:2 and ammonium carbonate, hydrated ammonium carbonate is X ratio 0.08. So we have 0.04 moles of ammonium salt and mass of is mole into mR. Mole is 0.04 into 114 mR of this compound. So we get 4.56. So this is the answer. A is the best option. When lead 2 sulfide is heated in air, sulfur dioxide and lead 2 oxide are formed. What is the equation for the reaction between lead 2 oxide oxygen? So lead 2 oxide plus oxygen to form sulfur dioxide and PbO2. Oxygen, number of oxygen atom over here product side is 4 and over here 2. So by placing 2 we get the correct chemical equation. So A option is correct. Next question. Which volume of hydrogen measured under room condition is produced when 0.16 gram of methanol react with an oxygen of what volume of is produced when methanol CH3 which volume of hydrogen measured under room condition is produced when 0.160 gram of methanol react with an excess of sodium? So this is CH3 ONA plus half H2. Uh, so this is 0.16 gram. By using this formula, mass over mR 0.160 divided by 12 plus 4 plus 16 is equal to 32. 0.160 divided by 32 is equal to, so by using mole ratio 1 ratio 0.5, 0.00, 5 ratio x into 0.5 is equal to 2.5, 0.0025, and volume is mole of hydrogen, and volume of hydrogen is 0.0025 into 24,000 is equal to 60 centimeter cube. So this is 60 centimeter cube. So next question is so this is the next question. A sample of hydrocarbon C6H12 is completely burnt in dry oxygen and the product gases are collected as shown. Water plus carbon dioxide plus excess of oxygen. So this is the increase in mass of the collecting vessels P and Q are MP and MQ. MP is the water and MQ is the carbon dioxide. So the ratio of MP over MQ, so water is absorbed by calcium chloride and soda lime, carbon dioxide is absorbed by soda lime. The ratio would be, so this is 18, MR is 18 of water and MR of carbon dioxide is 44. So the ratio between MP over MQ is equal to 18 over 44. So this is equal to 0.41. So in this question, you know that 0.216 gram of sample of an aluminum compound X reacts with an excess of water to produce a single hydrocarbon gas. This gas burns completely in oxygen to form water and carbon dioxide only. The volume of carbon dioxide at room temperature and pressure is 108 centimeter cube. What is the formula of X? So by using AlC, aluminum carbide plus water to form CxHy. CxHy further react with oxygen to form carbon dioxide and water, and which has 108 centimeter cube gas is produced. By using mole is equal to volume over molar gas volume, we get mole of carbon dioxide 4.5 into 10 raised power to minus 3. So mole of carbon dioxide is equal to mole of carbon. We know that if 0.045 mole 0.0045 mole of carbon dioxide, it gives 0.004 moles of carbon. So by using 1:1 ratio, so this is the mass of carbon by reacting the 4.5 into 10 raised power to minus 3 into 12 mole into AR. We get mass of carbon is 0.054 gram, and we know that 0.216 gram is the mass of aluminum compound X react with an X compound. So AlC ratio CxHy. So mass of aluminum is 0.216 216, and this is the mass of carbon, 0.054 gram. So we get mass of aluminium from aluminium carbide, aluminium ratio. So calculating the empirical formula, we have mass of aluminium and carbon 0.162 ratio 0.054 divided by 27 divided by 12. So this is 1 ratio 1.3 and multiplied with 3 by having whole number. So this is 4:3. The answer is aluminium 4C3. So we can calculate, this is the direct short method in this question. Aluminium carrying 3 plus, carbon carrying 4 plus, 4 minus. So by using cross multiply we get this formula. We can calculate if we use these values by using this. Which equation correctly describes the complete combustion of an alkene CnH2n? CnH2n plus 3 half NO2 and CO2 2NH2O. So this is the, because CnH2n, water is 2, hydrogen is 2 and oxygen is O2. So total oxygen is 2 and 1 3. So by 3/2, by balancing 3/2, we get the moles of number of atoms of oxygen equal of number of oxygen on product side is equal to the number of oxygen on the reactant side. So this reaction is correct option. So next question is, the airbags in cars contain sodium azide and an excess of potassium nitrate. In a car accident, the reactions shown occur producing nitrogen. This causes the airbag to inflate rapidly. So we know we have two equations. To balance these equations, these two equations, we multiply this with the 5. So we get this equation like 10Na3, 10Na plus 15N2, and we know that total number of nitrogen is over here 1 nitrogen and over here 15 nitrogen. So total nitrogen mole is 16 moles are there. So by using mole ratio, 10 moles producing 16 and 1 ratio could be X. So the mole is equal to 1.6. So this is the best option. B is the best option. Next question is tetraethyl lead has been used as a petrol additives. What is the percentage by mass of carbon in tetraethyl lead? So tetraethyl lead MR is 323, in which carbon is 96. So what would be the percentage by mass is 100 ratio X. So 96 into 100 divided by 323. So this is equal to 29.7. So next question is, a piece of rock has a mass of 2 gram. It contains calcium carbonate but no other basic substance. It neutralizes exactly 36 centimeter cube of 0.500 mole per dm cube hydrochloric acid. What is the percentage of calcium carbonate in 2 gram of piece of cork? This is the reaction. Calcium carbonate react with HCl to form water and carbon dioxide. Mole of HCl 0.500 into 36 centimeter cube divided by 1000. This is the mole of NaCl, and by using mole ratio 1:2, HCl is 2, and we get moles of calcium carbonate is 0.009. So mass of calcium carbonate is 0.9. 0.009 into 100 is equal to 0.9 gram. So the percentage mass of calcium carbonate is 0.9 divided by Actual mass of ore rock piece 2 gram into 100, that is 45%. So B option is the correct option. The compound S2O7 is hydrolyzed by water to produce sulfuric acid and oxygen only, which volume of oxygen measured at room temperature and pressure is evolved when 0.3252 gram of S2O7 is hydrolyzed. So this is 24 centimeter cube. The answer is 24 centimeter. How we reach this option? So S2O7 plus 2H2O to form 2H2SO4 and H2O2. The mole of S2O7 is 0.325 over 176. This is equal to 0.002. By using mole ratio, we get 0.001 mole. And volume of oxygen is 0.001 into 24,000, which is equal to 24 centimeter cube. So this is all about the mole question up till to 2022, from 2015 till 2022. Hopefully you understood this and you like this video. If you like this, please subscribe the channel and hit the like button. Thank you.